Hey everybody, I'm trying my best to keep this video as short as possible, but this is going to be a crash course on how to transform a graph, specifically the cosecant function, equation, ratio, whatever you want to call it. Cosecant is the reciprocal, not inverse, not opposite, reciprocal of sine, and that is going to be important to our journey over here. Our inputs, like the first two videos in this playlist related to trig, our inputs again are going to be the quadrantal angles. So those are going to be angles in radians. Angles, radians like 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are angles, radiant measurements. I'm not using degrees. Let's not be silly. And those are your inputs, inputs, the thing you put in your equation. Those are your x-axis, your horizontal axis, in this case, my theta axis. My outputs are the answers I get out of putting that thing in. The outputs are going to be what is the cosecant of those angles. Those are going to be on this circle just to save us from overcrowding, and those go on your output axis, which is vertical, in this case my y-axis, whatever it is called in a future word problem. Okay, so now in order to figure out what cosecant equals in your head, in your brain, you probably want to know what sine equals, and then just find the reciprocal. So if I go around, what are the angles? Let's go back to the black marker for this. If I want the angles, those are going to be the same quadrantals we've been using. We got 0, we got pi over 2. No, this is not black. This is gray, and it looks bad. 0, pi over 2, pi, 3 pi over 2, 2 pi. Those measurements are my inputs. That's where all the good juicy stuff happens. 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay? There we go. Output, keep the black. Output, now, use your brain. Sine equals 0 here. So cosecant equals undefined. The reciprocal of 0 is undefined. Sine equals 1 here, the reciprocal of 1 is 1. Sine equals 0, so cosecant is, again, undefined. Sine equals -1, reciprocal of -1 is -1, and again, finish it up at undefined. Our full period is 2 pi, it takes the full circle for it to start repeating its values at all the coterminal angles. The formula for the period is still 2 pi over b, and the quarter is still 1/4 of the period. That part is going to stay the same. Now, what things are going to be different? A bit. So, oopsie whoopsie, if I go over here, didn't label this, so we got 1, 0, and -1. Okay. Where do I start? If I were to graph sine on here, I'm not drawing it solid because it's not really there. I'm drawing it dashed on purpose. There's my sine wave. Can you see it? I think so. All right, I promise I have a dashed sine wave right there. I'm graphing the reciprocal of that, okay? I'm graphing the reciprocal of that. What's the reciprocal of 2? 1/2. What's the reciprocal of 1/2? 2. What's the reciprocal of 1/3? 3. What's the reciprocal of 4? 1/4. And so on. Reciprocal again of 0 is undefined, right? And of undefined is 0. Okay. Where your graph is undefined, you can't have any graph there, so we're going to have graph repellent laid down. So where the graph is undefined, there and there. How do I lay graph repellent? Well, I'm going to go over here. It's undefined at 0. It's undefined at pi. I'm drawing a dash line. This is a different dash line. The sine wave that I drew dashed, that's just there as an underlying structure. These are for the purpose of being asymptotes. Graph will not go there. They are vertical asymptotes. Asymptote, asymptomatic, no symptoms or characteristics of the graph. All right. Now, everywhere else, how do I draw cosecant? By finding the reciprocal by finding the reciprocal values for each of the sine values. I'm just trying to pick what color marker is going to show up the best. I'm going to use like a brownish color. I need something like, you know. Okay, what reciprocals stay the same? 1 stays 1 and -1 stays -1. So those points are on both sine and cosecant. Now somewhere in here, specifically, if we want to be particular, at pi over 6, sine equals 1/2. That means when sine is 1/2, cosecant equals 2. If that's 1, then 2 is like up there, pretty high up. Same idea at 5 pi over 6, which is right before pi, where sine equals 1/2, cosecant is going to equal 2. So this graph is going to have these U shapes, okay? They're going to keep getting wider forever and ever, but they're restricted between, kind of like bumpers for bumper bowling, these asymptotes. Okay, it does not cross over. Do not get reckless. Okay, so that little U shape, that is cosecant. And similarly, for the exact same reasons, you'll have that there as well. Okay, so scooch in the paper so you can see. And similar to sine, the graph goes on forever for the sine. Well, then these little U's continue forever. Boop, ba-doop. If I can make a stamper of this, stamp, stamp, stamp in both directions forever. So what does that tell me about my domain? Buckle up. Okay, my domain and my range. The range is easier, so let me do the range first. The range from bottom to top goes from -infinity, because it is pointing down, forever. Okay, it's going with all the y values forever. So I'm doing the range first. Until, in this case, -1, which is included. A U union symbol. We use this in the videos for the reciprocal and volcano. And from there, I pick up again at +1 and goes till infinity. We never reach infinities, so we use parentheses. So there's my range. Domain. Where do I want to write this? Because I don't really have the room. What did I think about writing it there? I'm just going to write it right over my graph. I get into this in other videos more. Go look for them on my graphing trig playlist. But basically your domain is all real numbers except my asymptotes. So how do I say that in an articulate way? All real numbers. That R with the extra bar is a symbol for all real numbers. Such that it's like a CU to the side with a line in it. That means such that theta does not equal, so it could be all real numbers as long as theta is not equal to the following things. So I'm going to start my first asymptote, 0. Now I can't list them all. They go on forever in both directions. So I'm going to say 0 plus, now how far apart are my asymptotes? They're always pi units apart, in this case, pi. But I could add pi once, twice, 3 times, 4 times, any number of times, as long as it's a whole number of times, or I could subtract it. So I'm going to do pi n. So pi is being multiplied by n, comma, where n, now this symbol, but the other way, is an element of, and now this symbol, z with a line, the set of integers. So that was the set of real numbers, all real numbers. This is all integers. The integers are positive and negative whole numbers, so no decimal values. So I could either add 1n, 2n, 3n, 4n, or I can add -1n, -2n, -3n, or I could add 0n. Anytime I do any of those things, forever and ever in both directions, I will hit one of these asymptotes. So those are the bad values. Boom, there's your domain. Think about it, replay it. You're welcome. Okay, here, doing it with A, B, H, and K. What's that going to look like? Same as before. K is our sinusoidal axis. If I add my amplitude, my vertical stretch or compression in either direction, this is K plus absolute value A. This one is K minus absolute value of A, my high and low value that I'm concerned with, okay? Then H is right there. Then plus Q, dot, 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 plus Q. Why do I keep grabbing this marker? Go away. Ooh, that one's okay, right? Right? We're probably going to need a common denominator. Keep that in mind. What can I quickly draw? Let's draw my vertical asymptotes are going to be in the same place. It's going to be, here's a trick that I like to give, is the number of syllables in the full word. So in this case, COSECANT, 3 syllables. COSECANT, that's the number of asymptotes you'll have in one full period. So first, middle, last. COSECANT. Secant will have 2. Tangent will have 2. Cotangent will have 3. Sine and cosine, we hopefully know at this point that they don't have any. If it is positive cosecant theta, you would draw a positive sine wave, right? But then you draw the little u guy, because that's really what cosecant is. So that's positive cosecant, okay? Versus, I'm running out of colors, you know, like to make it all look different. And then negative cosecant, that's gray, not black. Not sure if you could tell. You would go that way, that way. Those are included still. Little u guy, boop-a-doop-a-doo, arrows on the end, little u guy, arrows at the end. And there you go. All right. Domain and range, I mean, same concept here. Going too long. A little better for time for what it is. The domain, again, all real numbers such that that's not theta. Theta, theta, theta. There should be a theta. Theta does not equal h plus p over 2, half the period, n, comma, where n is an element in the set of integers. That's an h. That's an n. That's an n, if you could read it. And the range is always from negative infinity until k minus absolute value a, bracket, running out of room, union, bracket, k plus absolute value of a, comma, infinity with a parenthesis. All right? That's with using the letters, okay? If you can't read my handwriting, re-listen to what I said, because I said it while I wrote it. Let's do one example and call it a day. What's the equation? I'm not color coding. Y equals negative 1/2 cosecant. Ooh, this one, my b value has a pi in it, which is telling me my h will not. Aha, it does not. It's just 9 plus 3, and we will see how it all works itself out. Do not panic. So let's go from here. Okay. This is 3. Negative 1/2, so a half up and a half down, so 3.5, 2.5, good enough. So I used that already, and I used that already. Negative cosecant, let's just go ahead and graph it already. So I'm going to draw negative sign. We don't need to have it all labeled to draw it, right? Negative sign, and then I'm just going to use the wider edge. I'm going to have vertical asymptotes, cosecant, first, middle, last. Looks like that. And then my little U shape, boop, boop, ba-doop, it's going to go toward the asymptotes and touch that point. If it doesn't touch that point, you're not doing it right. Do it correctly. H, this is plus 9, so it moves left 9, so that's really negative 9. Negative 9 right there. Now, period stuff. Period equals 2 pi over b, which is pi over 28. Keep change, flip. So it's 2 pi times 28 over pi. Pi's reduce out, and we get 56 is the period. That's equals. And then Q is equal to 1/4 of that. 4 more is 60. A fourth of 60 is 15. So a fourth of 56 is 14. So Q is 14. So I'm just going to add 14 to negative 9. That gives me 5 plus another 14, 19. 14 more, 19, 29, 39, 33. 14 more, 33, 43, and 4 more, 47. Basically done. Just domain and range. Domain, all real numbers such that theta does not equal -9 plus, how far apart are they? Well, half the period or double the quarter. So 28 n, comma, n is an element in the set of integers. All right, range is -infinity, comma, 2.5, bracket, union, bracket, 3.5 until infinity. Whew. You're welcome. Thumbs up, just because I'm exhausted over here trying to bang out these fast-spoken videos. They all exist on the channel already, but I'm trying to just crash course it for everybody that's studying for their final exams. So there you go. You're welcome. If you appreciate, thumbs up, question, comment, concern, put it in the comment section. Links to more videos are in the description box and in the click through at the end. And if you just go to my page and click playlist and just scroll and read. I try to make the thumbnails and titles pretty straightforward, and you will be good with that. Hopefully I can just do less detail in the next one. Thanks so much, and bye.